Look around you, from the car you drive to the device in your hand and the beams holding up the roof over your head. Steel is the invisible skeleton of civilization, but before it was a skyscraper, it was just red dirt. Our journey starts deep in the earth. The recipe for steel is deceptively simple, but the scale is gargantuan. We need three main ingredients: iron ore, coal, and limestone. Massive excavators in places like Australia or Brazil dig up millions of tons of iron-rich rock. But you can't just build with ore. It's brittle and full of oxygen. To turn this rock into metal, we have to travel from the mine to the most intense environment on the planet, the blast furnace. A blast furnace is a 30-meter tall chemical reactor that never sleeps. It runs 24/7 for years at a time. We charge the furnace from the top with iron ore and coke, which is coal that's been baked to remove impurities. As these materials drop, we blast 1,200-degree hot air into the bottom. This creates a chemical tug-of-war. The carbon in the coke strips the oxygen away from the iron ore. What's left? A heavy, white-hot stream of liquid metal called pig iron. But here's the catch. Pig iron isn't steel yet. It's actually too carbon-rich, about 4% carbon, which makes it as brittle as a ceramic plate. To make it steel, we need to get that carbon level down to less than 1%. To turn iron into steel, we use one of two methods. The first is the basic oxygen furnace. We blow high-purity oxygen onto the molten iron at supersonic speeds. This literally burns off the excess carbon and impurities in a spectacular display of sparks. The second method is the modern hero of sustainability, the electric arc furnace, EAF. Instead of starting with raw ore, the EAF uses 100% recycled scrap steel. Think of old cars and demolished buildings. We lower massive graphite electrodes into the scrap and strike a literal bolt of lightning through it, melting it down in minutes. This is why steel is the most recycled material on Earth. The steel in your kitchen might have once been part of a 1950s locomotive. Once the chemistry is perfect, we have liquid steel, but we can't ship a liquid. We use a process called continuous casting. The molten steel is poured into a mold and cooled by water sprays, emerging as a solid, glowing ribbon of metal. Depending on the final goal, these slabs are sent to the rolling mills. Imagine a giant industrial pasta maker. Huge rollers squeeze the steel under immense pressure, thinning it out into sheets for cars, or shaping it into the massive I-beams used in construction. Cold rolling it further increases its strength, giving it the structural integrity to support the weight of a 100-story building. Finally, the steel arrives on site. In construction, its high strength-to-weight ratio allows us to build higher and safer than any other material. It's flexible enough to sway in an earthquake, yet rigid enough to hold thousands of tons of concrete. From the crust of the earth to the reach of the clouds, steel is the material that built the modern world. And because it's infinitely recyclable, the beam being placed today might be part of a lunar base 100 years from now.